Hello to everyone. Today we are going to explain about our final year project, heat transfer augmentation by using AgSiO2 nanofluid. Coming to introduction, most of the heat transfer enhancement methods are restricted by the thermal conductivity of the conventional fluids. So one of the way to overcome this problem is by replacing the conventional fluids with some high thermal conductivity fluids, which we used as nanoparticles to improve the thermal conductivity of the fluids. So coming to the abstract, using the nanofluids we can improve the thermal performance of the heat exchanger, even it has a compact design also. So here we are using the AgSiO2 nanoparticles for heat transfer augmentation. Coming to methodology, fabrication of heat exchanger, preparation of nanofluids, experimentation, results and analysis. This is the layout of our experiment. Here we are having a heat exchanger, shell and coil heat exchanger, which it is connected to a hot circuit and cold circuit. Here the hot fluid flows through the copper coil, and the cold fluid flows through the shell. Here all the arrangements are done to get our required values like temperature and pressure inside the circuit. And this is the final experiment setup which we use to test our nanofluids. And coming to the preparation of nanofluids, there are two methods, single step method and a two-step method. In single step method, simultaneous preparation and dispersion of the nanoparticles is done, and two-step method, separate preparation and dispersion. Coming to the calculation, water is used as a base fluid, and weight of the nanofluid is we use by nanoparticle density by base fluid density. According to that, we got 0.75 grams per liter. Like that, we had done the three concentrations: 0.1 concentration, 0.25 concentration, and 0.5 concentration. And experimental procedure is initially nanofluid and water are filled in their respective tanks, hot and cold circuits. We will switch on the power supply and set the mass flow rate in both nanofluids and the cold fluid. We will put the input power of a heater by adjusting the dimmer-stat, the auto transformer. We will run the experiment until it reaches the steady state. We will note down the temperatures and now bring the dimmer-stat to 0 position and turn off the power supply and repeat it 3 to 4 times until we get the respective values. Coming to result and analysis, this is the Reynolds number versus heat transfer coefficient. Here we can see the heat transfer coefficient of water and 0.1 concentration fluid, 0.25% and 0.5%. So by using this, we had drawn a graph. It shows the graph of Reynolds number versus heat transfer coefficient of the 4 different values. Here we can clearly see that the heat transfer coefficient for 0.5 concentration fluid is very high compared to other fluids, and this is the Reynolds number versus Nusselt's number values. Here also we can see the values for the 4 things, and the graph, it clearly shows that Nusselt number is increases, by which we can say that the heat transfer property increases. Coming to the advantages, increase in the effectiveness makes the heat exchanger compact, less volume of nanofluid is sufficient than compared to the conventional fluid. And finally, the conclusion of our project is heat transfer rate is increased by 8.5% for 0.5 concentration, and heat transfer coefficient is increased by 18% for 0.5 concentration. Nusselt number is increased by 15.4% for 0.5 concentration, and there is no change in the friction factor. So finally, what we conclude is that we can use the nanofluids in the heat exchangers like radiators and other things, where we can use a very compact heat exchanger to get the high effective results. So thank you